Hi everyone. So for this video we're going to be looking at algebraic limits. And so a lot of things that we've been doing so far has been looking at graphs or tables to kind of figure out what the limit is, but we're actually going to compute them algebraically in these set of notes. So let's start at the beginning. Recall what is a limit. So if you recall, let's see, the limit is the y value of a function that is being approached. The y value of function approaches at a given x value. All right. And so like I said, let's talk about some methods for evaluating limits precisely. So the first thing is there are these limit laws, and honestly, you want to know these limit laws because it's going to help you simplify in order to evaluate the different types of limits that we're going to be doing. So they're pretty intuitive. You probably already know them because we kind of use them a lot in other ways, but let's just kind of dive in. So it says assume that limit as x approaches a of f of x equals L. So I'm just going to kind of highlight, bold this right here, and then the limit as x approaches a of g of x is equal to m. Assume that they exist, and c is a real number, and m is greater than 0, and n is greater than 0 are integers. Okay. So for the sum, notice if I want to find the limit as x approaches a of f of x plus g of x, that is the same thing as the limit as x approaches a of f of x plus the limit as x approaches a of g of x. So that is really, if we're going to use this notation here with L and M, that's the same thing as L plus M. And if you're a little confused about what I just said, take a look at the answer key. I believe in the answer key I forgot to use L and M, but here we'll use L and M just because it's less to write. Alright, so looking at the difference, it says the limit as x approaches a of f of x minus g of x. Well, that's the same thing as the limit as x approaches a of f of x minus the limit as x approaches a of g of x. So in this case, it would be L minus m. Constant multiple, limit as x approaches a of c of f of x. So see this c, that's your constant. Essentially what we're doing, we're just going to pull it out. So it's really c times all of that. So in this case, it's going to be c times the limit as x approaches a of f of x, which is defined as L in this example. Product law, limit as x approaches a of f of x times g of x. So basically that's the limit as x approaches a of f of x times the limit of f of as x approaches a of g of x. So in this case it's L times m. Quotient, so I'm sure you've probably already figured this out. That's the same thing as L over m, but we also have to make sure we say that m cannot be 0, right? We're dividing, so we can't have 0 in the denominator. And then for the power law here, this is the same thing as the limit of x as x approaches a of f of x, the whole thing raised to the n power. So that would be like L, as it's defined here, to the n power. Okay? It seems harder than it is. It's just a lot of writing and notation, but let's just dive into a couple examples here and you'll see how we can use them. Alright, so suppose the limit as x approaches 2 of f of x is 4, the limit as x approaches 2 of g of x is 5, and the limit as x approaches 2 of h of x is 8. Use the limit laws to compute each limit. So when we're using these laws, you need to be sure you know which law you are using. But this is kind of like, I tell students this is very similar to when we expand those log functions. So you know you had to condense and expand logs. This is very similar to expanding. You want to essentially get each of these things by itself. Alright? And then we're going to substitute. So again, let's just kind of dive in. If I look at part A, the first thing I notice is this division. So this is the same thing as the limit as x approaches 2 of f of x minus g of x divided by the limit as x approaches 2 of h of x. So the first thing is I kind of split it, so it was all condensed into one, and I split it. And which law did I use? Well, I used the quotient law. All right. I'm going to expand it even more, and so I notice, see how these are kind of together right now? I'm going to separate those two, and so this is going to be the limit as x approaches 2 of f of x minus the limit as x approaches 2 of g of x all over limit as x approaches 2 of h of x. And so what law do we use? Well, we use the difference law. Okay, so make sure you can identify which law you used. And then notice each of these things have been expanded out and they're alone, right? And so I can now substitute. So this, right, is equal to 4. So this gives me 4 minus, and then I have this part here, which is defined as 5. And then the last one here, this bottom one, is defined here as 8. And then we just simplify this one. And so if we simplify that, we will get 4 minus 5 over 8, which is 1/8. So the limit of all of that stuff together is just equal to, negative 1/8. I forgot the negative. All right, so that's just an example of how we expand it out and use the limit laws to do so. All right, so let's do this again, and let's do part B. So let's see, because I definitely don't have room for all these other ones, but let's do part B. So the first thing I notice is, let's see, I'm going to see how this right here has a plus, so I'm going to start with that. I'm going to say the limit as x approaches 2, 6 f of x, g of x, plus the limit as x approaches 2 of h of x. So I've kind of gotten that alone. So what law did I use here? That's the sum law. And let's see, what's the next thing? I notice all this stuff here, right? So let's kind of separate that a little bit. So maybe I'll take the 6 out first. So let's see, this becomes 6 times the limit as x approaches 2, f of x, g of x, plus limit as x approaches 2 of h of x. All right, and what law is that? That is the constant multiple law. Okay, and I notice these are still together, so let's separate that out. So this is 6 times the limit as x approaches 2 of f of x, but then it's also, because it's multiplying, limit as x approaches 2 of g of x, and then plus limit as x approaches 2 of h of x. All right, and what law was that? That was the product law, right, because it was multiplying. And then I think we're done, right? Everything has been isolated, so this gives me 6, and let's see, this is defined as 4, so 6 times 4. This is defined as 5, and then it's plus that, which is defined as 8. So 6 times 4 times 5 plus 8 gives me 128. And there you go, there's part B. All right, let's do part C now. And let's see, part C. Okay, so this is going to have to deal with the power, right? So this is the same thing as the limit as x approaches 2 of g of x, and the whole thing to the third power. So that is the power law. And, well, that's it, right? We've kind of isolated that. So this right here is defined as 5. So this is really 5 to the third, which is equal to 125. So there we go. We only had to use one law for that one. All right, so let's talk about how to find limits. So we use limit laws to help evaluate, but actually finding a limit, there's a few different things we can do. We're going to start with the easiest method first, and that is direct substitution. That's going to be the easiest thing you're going to want to do. That will eliminate a lot of stuff for you if it works, okay? And you'll see what I mean when I say if it works. The second thing, or second strategy you can use is simplify. And then try direct substitution. And notice again I say try, because, you know, it may not work, but, and what do I mean by simplifying? Well, there's a couple different ways that we can simplify it. One of them requires factoring. I know some of you do not like that, but we're going to be doing some factoring. And when you factor, you'll see that some stuff will cancel. Okay? And then the second way we can simplify is rationalize. You know, if you see, especially if you see square roots, that's just kind of a hint. And so I'm going to pause right here, and I'm going to say, if you struggle with all of this stuff here, please go back and look at, you know, how to do that, how to factor, how to rationalize, because those are really important, and you're going to see when we do some of these examples that you're going to need to know how to do that. So please go back and look at how to do that. All right, so let's take a look at some of these examples, and you'll see what I mean. Okay, so we're going to evaluate these limits analytically, so no graphs, okay? And like I said, the first thing you want to do is try direct substitution. So I'm looking at this first example here, and we're looking for the limit as x approaches -1 of that function. So if I'm going to try direct substitution, it's exactly as it sounds. If it's approaching -1, let's see what happens when it actually is -1. So I'm going to see, if I plug in -1, do I get a value? And in this case, if I plug in, so let's see, -1 squared is 1, -2, -4, so I get -5. Great, works. I got a value. So let's try part B, same thing. Try direct substitution first. So if x is actually 2, let's see here, this is separated here, so 3 times 2 minus 2, so that gives me 6 minus 2 square root of 4, which equals 2. Beautiful. 2 in a row, direct substitution. Great. Have a feeling that's not going to work on the next one. Could never be that lucky. So part C. All right, so we can see that direct substitution is not going to work here, because if I do that, if I put 0 into the bottom there, we're going to have 0 in the denominator, which cannot happen. All right, so direct substitution didn't work. So now we're going to try simplifying. And the first hint is try to factor. So let's see. This is the same thing as the limit as x approaches 0. And if I factor the numerator, I see there's a GCF of x. So if I pull out an x, I'm left with 4x minus 5 over x. And this is why factoring is nice, because it cancels out some of the factors. And so really this is kind of simplifying to the limit as x approaches 0 of just 4x minus 5. So now at this point, and remember, x can't be 0, right? So we got to make sure we remember that. But let's plug in 0 here and see what the behavior is for the simplified version. So if I plug in 0, I get 4 times 0 minus 5, which is negative 5. So the factoring and simplifying worked, right, in the canceling. All right, so let's try part D. And notice it's the same problem as before. If I plug in negative 7 into where the x is, we're going to have a problem with the denominator. And so we can't do that. And so let's just try factoring again, see if that works. So direct substitution did not work again. You're never going to be that lucky, or they all will be direct substitution. All right, so let's factor the numerator. So if I factor the numerator, I have, let's see, 2x and x. So products, so minus 1, positive 7. And then I have x plus 7. Oh, great. I can see those are gone. Beautiful. So I'm left with the limit as x approaches negative 7 of 2x minus 1. And if we directly substitute, right, that's 2 times negative 7 minus 1. That gives me negative 15. Great. All right, so let's see, what makes this next one different? All right, so again, direct substitution is not going to work. If I plug in 5, I'm going to get 0 in that denominator, so no dice there. Now, we can't really factor that either, right? So if you notice, we have the square root of x plus 4, and then you have the minus 3. That does not factor. And so the only other option we have, if you go back to what, oh, I erased it, it's on the other page. The only other option is to rationalize, okay? So if you recall, when we rationalize, you want to multiply by the conjugate. And so I see this thing with the fraction, the numerator with the, or not fraction, the square roots. And so the conjugate of that is the square root of x plus 4. And instead of a plus or a minus 3, it's a plus 3. So we're going to multiply top and bottom by that. Okay. And that will actually help us, believe it or not. It's going to look a little messy, but, things will cancel and hopefully it'll work out for the best. So let's try. So the limit as x approaches 5. All right, let's multiply. So we've got this times this. So let's see. Square root of x plus 4 times x plus 4 is just x plus 4. Square root of x plus 4 times 3 is 3. X plus 4, right? And then negative 3. And slow down and pause the video if you're not seeing this, but I'm like kind of like foiling here. And then minus 9. And then I'm actually not going to multiply out the denominator, and you'll see why. But typically, if it's in the factored form, you'll see that things will end up canceling in the end. So, all right, so I see things have canceled already, so like those are gone, right? And then I can combine like terms here. So this becomes limit as x approaches 5, and up top I now have x minus 5, and on the bottom I still have those two. And this is why, as you can see, I did not want to just multiply the bottom out, because now those are gone, right? They cancel each other out. So this becomes a limit as x approaches 5. I have a 1 up top, and then I still got all that stuff on the bottom. Oops. Plus 3. Okay? And so now at this point, I am going to try direct substitution. And I'm running out of room here, so let me go up here, okay? So if I directly substitute the 5, I'm going to have 1 over square root of 5 plus 4 plus the 3. Well, notice this is square root of 9, so the square root of 9 is 3, so that's like 1 over 3 plus 3, which gives me 1 over 6. So yeah, it looks a little messy, but do a few problems, practice with it, and hopefully you will see that lots of things cancel and it won't be as bad as you think. All right, last one. Okay, again, we don't want to go through that mess again, so always try with direct substitution. So if I plug in -1, I'm going to get cosine pi times -1, which is cosine of -pi. And luckily that works nicely because the cosine of -pi is -1. So, whew, that was good. Luckily that worked. So there you go. So when finding limits algebraically, try direct substitution. And if not, you're going to have to simplify either by factoring or rationalizing. And so start practicing.